Hello viewers, in today's session we are going to discuss another important and very conceptual problem from Dirac delta function, right? And in this session we are going to evaluate this integral that is from minus infinity to infinity, and here we have a function f of 4 minus t and the Dirac delta function delta of 2 minus t dt, right? So here we'll see how we can evaluate this integral with the help of the concept of Dirac delta function. So let us start. So let us first call this integral as I, and here we'll make use of the concept of substitution method, and we'll take this argument, that is 2 minus t, as u, right? So let us substitute here. U is equal to 2 minus t, so that we can have t is equal to 2 minus u, right? So now differentiating both sides, we'll get dt is equal to minus du, right? Okay, now see here, the limits of integration vary from minus infinity to infinity. So when this t tends to in minus infinity, then the value of u, it tends to positive infinity, right? Because see here, u is equal to 2 minus t. So when t tends to minus infinity, u tends to 2 minus infinity, that is tending to 2 plus infinity, that is tending towards infinity, right? So when t tends to minus infinity, u tends to infinity, and similarly when t tends to positive infinity, then u tends to 2 minus infinity, and 2 minus infinity tends to minus infinity, right? So now this integral I can be transformed in terms of u as positive infinity to minus infinity, because when t is tending towards minus infinity, u tends to infinity, and when t tends to positive infinity, u tends to negative infinity, right? And here we have f of 4 minus t. So let us replace this t by 2 minus u, right? And here we have delta of 2 minus t. 2 minus t is u, so we have simply u. And for dt, we can write minus du. So now let us rearrange the terms or simplify this expression here. So we have plus infinity to minus infinity. This negative sign can be taken outside the integral, and we have f of 2 plus u, because here 4 minus 2 is 2, and negative times negative, here we have positive, right? And we have delta of u, and here we have du, right? Now here we have this negative sign, so we can now interchange the limits. So we can now write minus infinity to infinity f of 2 plus u, and here we have delta of u du, right? So here we have used an important property of definite integrals, that is a to b. Say f of x dx is equal to negative of the integral from b to a, and f of x dx, right? So interchanging the limits will get a negative sign in front of the integral, right? So now due to this substitution, we have transformed this integral to this one, right? So now see here, we have u, and we can write this integral as minus infinity to infinity f of 2 plus u, and delta of u can be written as delta of u minus 0, right? And to evaluate this integral, we can make use of this definition of delta function, that is minus infinity to infinity. And if we have a function f of x associated with the delta function, that is delta of x minus a dx, then the value of this integral is equal to the value of this function at this point, right? So we have here f of a. So utilizing this property, we can now write the value of this integral. So here we have u minus 0, and here the value of a is equal to 0. And for the function f of x, we have f of 2 plus u, right? So we can now take a is equal to 0, that is u is equal to 0, and we can evaluate the value of this function at this point, that is u is equal to 0. So the value of this integral is equal to the value of this function at this point, u is equal to 0. So we have 2 plus 0, that is equal to f of 2, right? So taking u is equal to 0, f of 2 plus u takes the form f of 2 plus 0, that is equal to f of 2, right? So the value of this integral is equal to f of 2.